Hello everyone, welcome to session 1 of module 2, Software Development Models. In this session, I will cover different software development models and how testing is done throughout the software lifecycle. So testing is not a standalone activity. It does not exist in isolation. Testing is dependent on what type of software development lifecycle is being followed. So depending on the development life cycle, testing fits in that life cycle, and testing is done in every phase of the development life cycle. So if you're following waterfall development methodology, testing has its own place in that software development model. If you're following V development model, testing has its own place in V development methodology. And it's not a standalone activity, it's present in whole development life cycle. It's a life cycle activity and it does not exist in the isolation. So testing has its place in SDLC. Depending on the development life cycle, testing has its place in that SDLC. If it's a waterfall model, if it's a V model or agile development methodology, testing has its place in every methodology. Then the selection of software development model decides how testing will be organized in that methodology. So if you're selecting a waterfall development model for developing a software, the organization of testing in waterfall development methodology will be different than the organization of testing in V development model. So depending on the model, on the development model that you choose for developing any software, testing organization changes accordingly. So in V development model, organization of testing will be different than the organization of testing in waterfall development model. Similarly, in agile development methodology, testing organization will be different. So the selection of software development model decides how testing will be organized within that development model. Then there are different test levels in SDLC. So in software development lifecycle, there are different test levels. So the first test level you can say is unit testing, which is mostly done by the developers. So they do the coding and then they write unit tests for the code that they have developed, whether those smaller chunks, smaller modules are working fine or not. Okay, then you have integration testing, then you have system testing, and then you have user acceptance testing. So we'll cover all these test levels in detail in further sessions. So there are different test levels in development life cycle. Then software development model. So there are different software development models. So the initial model is waterfall development model. Then to overcome some shortcomings of waterfall development model, V development model came into picture, which overcomes some of the shortcomings of waterfall development model. Then there came in few more development models like iterative development model, which have rapid application development and agile programming. Agile is the latest one nowadays. Then some development methodologies are lightweight and fast methodologies, and some are more controlled and fully documented. So as many of you would be knowing that the initial development methodology, like the waterfall development methodology, was very controlled and fully documented methodology. What this means is, in waterfall development methodology, everything was completely documented. All the requirements were being finalized. Unless and until requirements were being finalized, you cannot go into the design phase. Once design has been fully documented and finalized and approved by all the stakeholders, then you go into low level design. Once low-level design has been documented and approved, then coding started. Once coding is done, finished, only then testing starts. So waterfall development methodology was very controlled and fully documented methodology. So but nowadays there are very lightweight and fast methodologies like agile. So agile development methodology is very fast and lightweight methodology because there is not much documentation involved. So very minimal documentation is done in agile methodology, and there are sprints of 2 to 4 weeks cycle. So in this time frame of 2 to 4 weeks, you have to design, develop, test and deliver, and after testing you need to showcase to the stakeholders whether the product that has been built in that sprint is meets end user requirements. So agile development methodology is very fast and lightweight methodology. Then development model defines what, where and when of our planned testing. So based on the development model that you choose, it defines how the testing will be planned in that development model. What you will test, where you will test and when will you test. So if it is waterfall development model, your test planning for waterfall development model will be like fully controlled and fully documented. For V development model it will be different. For agile methodology it will be different. So based on the development model, test planning is defined. Then the way testing is organized must fit the software development lifecycle. So your test organization, how you organize the testing, must fit the software development lifecycle. If you have chosen waterfall development methodology, your testing, the way that you organize your testing should fit waterfall development methodology. If you are following V development methodology, your test organization should fit that V development methodology. So based on the development life cycle, your test organization should fit. In every development life cycle, verification testing and validation testing is done. So based on different development methodologies, so whether it is waterfall, whether it is V or it is agile, in every development life cycle you do verification and validation testing. We'll cover difference between validation and verification in next slide. So verification is concerned with evaluating a product to determine if it meets the requirements. So verification is concerned just with the requirements. If you have the requirement, you have gathered software requirements, and you have approved software requirements specification document. So verification is just concerned with those requirements. If the software that you are testing is built as per the requirement, verification just checks that. So verification answers the question, is the deliverable built according to the requirement specification? If the deliverable is according to the requirement specification, that's fine. So that part is taken care by the verification testing. Validation, on the other hand, is concerned with evaluating a product to determine if it meets the end user requirements or end user needs. Okay. So there might be some requirement which is not correctly captured and the software is built as per the requirement. So verification won't be able to find the defects, those kind of defects. So validation is concerned with evaluating the product as per end user needs. So validation answers the question, is the deliverable fit for purpose? Okay. So validation checks whether the software that is being delivered is fit for use or not, whether it's easy to use or not. Okay, so validation is concerned whether a deliverable is fit for purpose. Now the first development model is waterfall development model. So in waterfall development model, as you can see, it was pretty straightforward. I mean, you have different phases in waterfall development model, and you could enter into another phase only if first phase has been completely finished and approved by the stakeholders. So the first phase of waterfall development model was the user requirements phase, in which business analysts or product managers gather requirements from end user or from the market. So depending on the kind of software that you are developing, if you are developing a software for the client, you gather the requirement from the client. If it is a software being developed for a mass market, then you gather the requirement based on the already available products in the market. You evaluate them and gather the requirements. Product managers gather requirement from competitors, from the actual end users that will be using those the software. So in the user requirements phase, you gather those requirements, you capture everything, you create a document, software requirement specification document. Once that document is created, it was sent for approval. Once all the requirements were approved, then you moved into the next phase, that is the global design phase. So in this design phase, all the high level design was being done. So how the system will be built, how what database integration will happen, what database will be supported, what web server will be used, will be supported. So all those high level design details were being captured into global design phase. So high level design document was being being developed, sent to stakeholders. Once design has been frozen, has been approved, then you move into the next phase, that is the detailed design phase. So in detailed design phase, you develop low level documentation, low level design document, which takes different modules in greater detail, and how you design different modules of the software, what will be designed like for smaller chunks, smaller modules of the software. So then after high level design, low level design was done and sent to all the stakeholders, product managers, technical architects for review. So once that design has been completely made, documented and approved, only then implementation or coding part started. So as you can see, in waterfall development model, you cannot move to next phase unless the previous phase or previous step has been completely completed. It's complete, it's approved by the stakeholders. So after the implementation, after low level design, developers start coding. Implementation, they do some implementation. Once the requirements are, some of the requirements are being bundled into the builds are given to the testers, which they install on the supported platforms and start testing. So after all the implementation has been done, testers start getting built, they start testing, they raise defect, developers developers fix the defects, and they keep on getting builds with new functionality, with defect fixes, and they keep on testing. So once testing is complete, all the Sev1 defects have been fixed, and the product or the software meets the exit criteria, it is being moved out of testing phase and is deployed. So after the deployment, after live deployment, then maintenance phase started for the software that is being deployed. So in waterfall development model, it was pretty, it was straightforward, but it was there was no kind of, unless and until you freeze the requirements, you cannot go to global design phase. Unless and until you freeze the design, you cannot go to low level design. So that was kind of drawback in waterfall development model. But since this was the first development model in the industry, so it was there for quite a long time. So to overcome the issues that were there in waterfall development model, another model came in that is known as V development model. So in V development model, if you see, testers were involved right from the beginning. So if you see the waterfall development model, testing came after 4 phases were done. So what if there were issues in the requirements? What if requirements were not being captured properly and are not testable? So testers never knew if the requirements are not even valid, if the design is not proper. So to overcome all these issues, because since the feedback from test team was not there in waterfall development methodology, so V model came in, wherein testers were involved in all phases of development life cycle. Because of all those issues in waterfall development methodology, there were a lot of issues. So suppose there was a requirement issue and requirement itself is not valid, so that used to be detected when testers start testing, and the organization has already invested money in requirements gathering, in designing, in developing, and then the testers found that the requirement itself is not valid, or the design, there are design flaws in the software. So at that point of time, the cost of again capturing correct requirement or redesigning is way high if it would have been detected well in advance. So in V model, testers are involved in all the phases. So right from the requirements, testers in the requirements phase, testers prepare acceptance test cases. So when the requirements are being gathered, they validate those requirements and they prepare acceptance test scenarios in that phase. Then in the next phase, in the system requirements, when system requirements are being gathered, whether which database will be used, how the design of the whole software will look like, testers prepare system test cases in that phase. They review the high level design, low level design in system requirements and global design phase, and prepare system test cases and integration test cases. So in global design, when developers or technical architect design do a high level design, then testers create integration test case. So they go through the high level design thoroughly and create integration test cases, and also validate whether the design is proper or not. Then in detailed design, testers create, it's mostly a developer's activity in detailed design. In most of the organization, you'll find that unit testing is done by developers, but yes, testers do provide input in unit test cases as well. So in detailed design phase, testers provide input in unit test cases, and then after detailed design, implementation is done, and then testers start. Once the implementation is done, testers get the bill after the unit test is done. So it depends. So there are organizations wherein unit testing is done by testers as well, but at most of the places you will find unit testing is done by developers. It's very rare that unit testing will be done by testers. So developers will implement the code, they will do the unit testing, and then testers will start integration test execution. They'll start integration test cases. Once integration test is being done, then they'll start system test cases, and then once system testing is done, they'll start the acceptance test cases. So V-model overcome all those issues that were present in waterfall development model. So in V-model, if there is any issue with the requirements itself, requirement is not valid, it is not captured properly, testers will point out that well in advance. If there is an issue with system requirement, or if there is an issue with design, so testers review all those documents and they provide feedback then and there, and which avoids a lot of rework and a lot of savings for the development. But in waterfall model, there was no feedback being provided to the previous phases, and because of that, if there was any design flaw or requirement issue, it took a lot of time and money to fix that. Then the other software development model is iterative development model. So in iterative development model, usually you have a time boxed iteration, say 2 to 4 weeks. So depending, I mean, there can be, if it is agile methodology, it will be 2 to 4 weeks. And there are some iterative development methodologies wherein you use more than 4 weeks as well. So there are different phases in iterative development model, wherein you capture the requirement, you develop, you build, test, and deploy. So like you can see in the figure, in phase 1 you capture requirement, you develop, build, test, and deploy. And then in phase 2, on top of whatever you have built, tested, and deployed, you again capture new requirements, you develop them, build them, test them, and again deploy them. All right. So that's how iterative development methodology is done. So you have time box iterations, and you do all your development activities in those time box iterations. So iterative development model, some of the examples of iterative development model are rapid application development and agile development. So rapid application development is also a development methodology which is iterative development methodology. So rapid application development, in this methodology, you develop all the functionality at once. So suppose you want to build something, so there are, say, 4 functionalities being developed in an application. So you develop, you define, some teams, small teams, and everything is built at once. So one team will build function 1, another team will build function 2, third team will build function 3, fourth team will build function 4. So what they will do is they'll define, develop, build, and test. So these teams will do all the development functionality, or they will gather they'll define, they'll develop, they will build, and they will test all the different functionalities, and then all these functions are integrated into one, and then a working product is being demoed to the stakeholders. So this rapid application development is quick and easy, quick methodology, just to give a rapid feedback to the stakeholders so that they are aware how the system looks like, okay, rather than spending months of effort in gathering requirement, design, develop, test, and then at the end of a year knowing that no, this is not what we wanted. So this rapid application development approach is is quite easier, and it takes less time and effort and budget. So every function is being implemented all at once and integrated with Big Bang methodology, integration methodology, and demoed or showcased to the stakeholder, and then these stakeholders decide whether to continue with the application that has been developed, whether it has been built as per requirements, or whether it will be, kind of whether it makes sense to continue with it, or whether to just discard it and start with some other idea, or start with some other modifications, and then go ahead with the development. So it gives very early feedback to the stakeholders and saves a lot of time and money for the organizations. Then you have agile development methodology. So agility is something to capability of rapidly and efficiently adapting to changes. So agile came from the word agility, and agile is capable of rapidly and efficiently adapting to changes. So that's where agile development methodology came from. And the purpose behind developing agile methodology was to have agility, which was missing in traditional development models. So if you consider waterfall development model or V development model, so there was very less chances of less agility there, because requirements has to be finalized, design has to be finalized, only then coding starts, then testing. So it was kind of very rigid approach towards developing the software, and that was not good, because if a stakeholder came in and he saw the software and he thought of, no, I don't like that and I want to get this changed, then he has to again, every process has to follow again. You need new requirements being captured, design, development, all that full full development flow has to follow again. So that was the drawback in all those previous models, be it waterfall or be it V development methodology. So agile development methodology has agility to rapidly and efficiently adapt to any changes or any feedbacks provided by the stakeholders. So agile development is based on iterative and incremental development. Okay, so agile is a part of iterative development methodology. So agile development methodology is a 2 to 4 weeks cycle. So depending on different organizations, they choose, some organizations choose 2 weeks sprint, or some organizations choose 3 weeks, some also choose 4 weeks sprints. So based on how the organization wants it, they choose those sprints, and then all the requirements are being gathered at once and lie into the product backlog. Once everything is there in product backlog, then these sprints start, and those requirements or user stories are being pulled from product backlog to sprint backlog. And then in sprint, there are scrum teams which take all those requirements based on different scrum team or different modules the scrum teams are being organized. So they take the requirements and they design, develop, test, and deliver a working product and showcase a working product to the stakeholders after 2 weeks or 3 weeks of sprint. And then after showcase, the feedback from stakeholders was taken, whether things were all right, whether they want some changes or something is not right, if something needs to be changed. All those feedbacks were taken, and then again in next sprint, those changes can be taken care. So agile methodology uses continuous stakeholder feedback to provide high quality consumable code through use cases and a series of time box iterations. So these time box iterations are known as sprints, and in these sprints you pull the use cases or user stories from the product backlog into the sprint backlog, and then you implement these user stories into a working product and then showcase these stories at the end of the sprint. And within these sprint, all the activity, your design, develop and testing activity takes place. So after testing, any defect raised is fixed by the developers and again retested. And once everything is tested and there are no critical defects, it is showcased to the stakeholder at end of 2 weeks or end of the sprint. And then any stakeholder feedback is taken and implemented, that feedback is again introduced into the next cycles of the product. So in next sprint, new requirements being taken, any feedback received from the previous sprint is being implemented, and so these sprints keep on going and the product is developed. The product is being developed with continuous stakeholder feedback. So in agile development, whatever requirements have been being implemented in the first phase needs to be regressed in the second sprint, and whatever requirement have been implemented in sprint 2 need to be regressed in sprint 3. So you can see, like, in agile development methodology there lies there is importance of automation very much, because you cannot in every sprint that you progress there will be new test cases coming in because new requirements are being coming in, and then there will be old test cases which need to be regressed. So that's a bit of agile development methodology. So conclusion. So in this session we learned about different software development models. So we started with waterfall development model, what were the drawbacks in waterfall development model, and how we model overcome those drawbacks. Then we got through iterative development methodologies and covered rapid application development and agile development methodology. Thank you.